You have terms, which can be a number, a letter, or a product of numbers and letters. And then like terms have identical variable portions. Okay, so let's do some comparisons. Okay. 3x and negative 7x are alike because they both have just a single x. So these are alike because they both have an x. Not alike, 3y and 3x. They both have a 3, but it's the variable part that has to be alike. So these two are not alike. I could do 3x squared and x squared. Those are alike. But 3x and x squared are not alike because while they're both x's, this is an x squared. So identical variable portions with identical exponents. Now all numbers are alike, 4 and 10, because they have no variable, so they're alike. And you can have combinations. So 3xy and negative 6xy. As long as the letters match, they're alike.
What if the letters got rearranged in a different way?
3xy, negative 6yx.
Yeah.
Those are still alike because they're the same two letters with the same exponents. So that would be okay. That's a really good question. Something called an algebraic expression, which is the sum of one or more terms. Generally, if we're saying it's an algebraic expression, it has a variable in it somewhere. Now, a term doesn't have to have a variable in it, but usually if we say algebraic expression, there's probably a variable in there somewhere. And the thing that makes it an expression, not an equation, is that there is no equal. Okay, so expressions don't have an equal sign. So you have variable terms. Those are terms that have a variable. Which is a letter. And you have constant terms. And these are numbers alone with no variable. Okay. You have what's called a coefficient. A coefficient is the number attached to the variable. And it indicates multiplication. Okay. So just for an example, this is an algebraic expression. You'll notice that I have pluses and minuses, but I have no equal sign. So it's an expression. These are variable terms. And this 6 by itself is a constant term. And why don't we do green? The 3, the 4, and the negative 2, these are coefficients. if we're going to list the terms, we basically take everything that's there. If there's a minus in front of it, we have to list it as a negative. Those are the terms. If there's a plus in there, you can just leave it alone because they're positive, so you don't have to put the plus there. The coefficients are the numbers that are attached to the variables. So my coefficients are 14, -6, and 3. So the coefficients are just the number part. The term is the whole thing, coefficient is just the number. But you'll notice I did not list this 5 as a coefficient because it's not a coefficient. It's only a coefficient if it's attached. Yeah, it's a constant. Okay. Which of the following are like terms? Yep. The two that have just a plain old x. And then are these like terms? 3x squared y and 5xy squared?
No.
No. They have both x's and y's, but here the 2 is on the x and here the 2 is on the y. That part has to be the same, exactly the same. All right, so we have some properties of addition and multiplication. These are not true for subtraction or division. Okay, that's why I said they're only for addition and multiplication. Okay, commutative property tells me that it doesn't matter what order I add in. So a plus b would be the same thing as b plus a regardless of what numbers those are. And just to prove it, 3 plus 6. 6 plus 3. 3 plus 6 is 9. 6 plus 3 is 9. It doesn't matter what order I add in. I'll still get the same answer. A way to remember that commutative property changes the order. If you think about your commute, you commute from home to work and then from work to home. Same distance, you just change direction. So that's commutative property. You're just changing direction. Okay, same thing with multiplication. A times b is the same thing as b times a. 2 times 3, 6. 3 times 2, 6. It does not matter what order I multiply in. Now, this won't hold true for subtraction because 3 minus 6 and 6 minus 3 are not the same. And the same thing with division, like 2 divided by 3 and 3 divided by 2 would not be the same thing. So it's only addition and multiplication that these are true for. Same with the associative property. Associations are groups, right? You have like the American Heart Association and trying to think of other big famous associations. Anyway, they're all groups, right? Big groups. So associative property changes the groups. Okay, so A plus B are together in a group, and I add C. It doesn't matter if I add A and B first and then add C, or if I add B and C first and then add A. It's all going to get added up, and it'll all total the same thing, right? So just to prove it, (4 plus 5 equals 9). 1 plus 8 equals 9. So it doesn't matter. Same thing holds true for multiplication. And you might think, well, why would we use this? Here's a good example of why you would use this. Let's say I have 10, no, not 10. Let's do 7 times 13. 7 times 5 times 2. I didn't change the group. Okay, 7 times 5 is 35 times 2. I do happen to know that, but let's say I just didn't know that. And then I'd have to sit there and write it out and do it. But I know that 5 times 2 is 10. So it would make more sense for me to multiply 5 times 2, which is 10, and then multiply that times 7, which is 70. So that's the purpose of this, is so that I can change what I do first to make the problem easier. Just in case you wondered, like, why? The title of this property is the distributive property of multiplication over addition. Nobody calls it that. We all just call it distributive property for short. But this is the whole title. And if you think about what does it mean to distribute something? Like if I'm going to distribute some flyers, I'm going to give flyers to a bunch of different people, right? I'm going to give every single person a flyer. So distributive property is like that. It's multiplication over addition. So if I have A times B plus C, what I'm going to do is I'm going to give this A to the B and the C. So it's A times B, A times C. And what I usually do is I draw little arrows to say, okay, I'm multiplying A times B, I'm multiplying A times C. And it doesn't matter if that A comes in front or in the back because multiplication goes in both orders. So I can take this A and I can multiply it by B and I can multiply it by C and I get the same answer, AB plus AC. The most often what you see for the distributive property is you'll see something like 3 times 2x plus 6. This is what you see a lot of in algebra. And so I take that 3 and I multiply it by the 2x and I multiply it by the 6. So 3 times 2 gives me 6, so 6x, and then 3 times 6 is 18. And it doesn't matter how many terms are inside the parentheses. I'm going to distribute to everyone. And so I'm going to get 2 times 4x, so that's 8x, 2 times 3y, and then 2 times negative 9. So I'm going to take whatever that multiplication is, I'm going to multiply every single thing inside that parentheses by the multiplication. So if I want to apply the commutative property, remember the commutative property is the one that changes the orders, like your commute, you just change direction. So this would equal p plus 6. I've applied the commutative property. I could write this as n plus negative 5, or if you like it better, you can write n minus 5. Those are the same thing. Y times 7 becomes 7y, and xy becomes yx. But just for future reference, this one is more proper because we like it to be alphabetical. They're the same thing, but this is more proper. Applying the associative property, the purpose of this, 12 plus 45 plus y. Well, I don't know what 45 plus y is because I don't know what y is, and I can't tell you what that is. It doesn't make any sense. So what I can do is I can change the grouping to do 12 plus 45 and then plus y. And I can tell you that 12 plus 45 is 57. So I changed the grouping to make the problem make sense. Same here, 5 and then 7y, but 7w. 7w doesn't mean anything really. But I can put 5 times 7 together and then multiply that by w, and that gives me 35w. When we apply distributive property, if it's a positive number out front, that usually gives no one any trouble. I do 3 times x and 3 times 4, and I get 3x plus 12. Here I have 2, so I do 2 times each. So 2 times 3y is 6y. 2 times negative 5z is negative 10z, and 2 times 1 is 2. If you have a negative number outside, you have to multiply by the negative. So this is negative 8 times positive 2, So that's going to be negative 16. And this is negative 8 times negative 5. So negative times a negative gives me a positive 40. Okay. And if you have just a negative out front by itself, it's kind of like a little invisible negative 1. So what I do is I multiply each of these things by negative 1 or change all the signs. So that negative out front makes that positive 4a, negative b, and negative 3c. So it just, there's not really a 1 there, but it's like there's a 1 there. So you just change all the signs. Now, the biggest mistake I see people make is when I have something like, say I have 2x minus 4 times 3x plus y or something like that. Because this is in front, they don't multiply the negative. You have to bring that negative in still. So you have this 2x is just hanging out. You negative 4 times 3x, that's negative 12x. Negative 4 times y, negative 4y.
So the two stay the same?
Yeah, I just brought it down. But that negative has to stay with that 4. Your negative is like your shoes. You're not going to leave your house and go anywhere without your shoes on. So, I mean, maybe your backyard, but you're not going to go places. So it's the same thing. The negative has to stay with the 4. It's like they're together. So that 4 is not going to go anywhere without it. So just be really careful of that. That's the biggest mistake I see made, is that people don't bring this negative in because there's something out in front. When the negative is by itself like this, no problem. But when it's got something in front of it, I think that gets confusing and they don't bring the negative through. So just be sure to do that. So bring the negative with you. I know, it's like your car keys. You're not going to get anywhere without them, right? So you'll hear collecting like terms or combining like terms. And basically these mean the same thing. We're going to add, and I'm going to put in parentheses or subtract, the matching terms. Okay, so if I have 8y and 6y, okay, this is 8 plus 6, so it's 14y. Now, do you have to add in this step and write that in there? No, you don't have to. I just wanted to show you what's happening. You add the coefficients. So you're going to add the coefficients. Okay. And if I have one that's positive and one that's negative, it's the same as if I just had 7 plus negative 10 or 7 minus 10. So I'm going to subtract because they're not the same. And I get negative 3 xy. The letters are not going to change. If I had 6x squared y minus 2x squared y, 6 minus 2 is 4, and it's still going to be x squared y. That part does not change. And if I have more than one, I'm going to say 15, say negative 15 plus 4 is negative 11 plus 3 is negative 8w. So I add them you know, I add these two first and then add the next one, or I could have added the two positive ones together first and then put it with the negative. But you just end up adding all three of them together eventually.
But you won't do it.
Okay, so if I have negative 3x plus 8y plus 4x minus 19 minus 10y. The first thing I want to do is I want to put all my like terms together. So I have x's and another x. Those are my x's, so I'm going to write those next to each other. And then I have y's. So I'm going to write those together. And then I have this lonely 19, so I'm just going to write him down. Then I'm going to put my like terms together. So negative 3 plus 4 gives me 1. 8 minus 10 gives me negative 2. And then this guy that had nobody to combine with, he just hangs out. So the first thing I need to do is distribute. So remember that negative has to stay with 3. So my 6 just hangs out. I have negative 3 times 2, so that's negative 6y. Negative 3 times 9 is negative 18. No, it's not. I lied. It's 27. It was 2 times 9, but it's 3 times 9, so it's 27. Now my like terms are the 6 and the negative 27. Those are the constants. Constants are like each other. So if you want, you can rewrite them together. You don't have to, but sometimes it makes it easier. So I'm going to combine these because they're alike. And so I get negative 6y minus 21. And that is my final simplified expression. So an expression is simplified. When all parentheses are cleared. This is what we did when we applied the distributive property. We cleared the parentheses, and like terms are collected. Now there will be some more rules for simplification to determine if something's completely simplified when we get into other processes, but for right now you want to clear all your parentheses and collect all your like terms. The addition and subtraction properties of equality, and basically what that means is we're going to use addition and subtraction to solve equations. Okay, so what's an equation? An equation, by definition, is a statement. It's a mathematical statement that indicates two quantities are equal. And that's the key, equal. An expression had no equal sign. An equation has an equal sign. Okay, so we can simplify expressions, but we can't solve them. Equations we can solve. And the solution is the value of the variable that makes the statement true. So when we're solving equations, essentially what we're doing is we are going on a scavenger hunt to find the number that we can plug in for the letter that makes a true statement. Because, for example, if I have x plus 5 equals 7, there's only one number I can put here that's true. 2, right? 2 plus 5 equals 7. I can't say, oh, x is 10. No, it's not.
Where did you get the 2 at?
X plus 5 equals 7. We're looking for the number plus 5 that equals 7, right? No, that's fine. But like I said, there's only one value that makes this true, right? I can't plug just any old number in there. It's got to be a 2. So 2, in this instance, is my solution. That means x equals 2. And x can't equal anything else because any other number I throw in there would be false. It has to be 2, right? Because 2 plus 5 is 7. But if I said, oh, x is 6. No, 6 plus 5 is not 7. Does that make sense? Okay. So expressions don't have equal signs. Equations do. Expressions cannot be solved. Equations can. So in order to solve, you have to have an equal. Okay? I ask you to determine if a number is a solution. Let's say I give you an equation, 2x minus 9 equals 3. And I want you to tell me, is 6 a solution? Well, we have to put the 6 in for the x and see, is it true? So I do 2 times 6 minus 9. 2 times 6 is 12. 3 equals 3. This is true. So yes, 6 is a solution. If I give you 20 is equal to 8p minus 4, and I ask you, is negative 2 a solution? Well, I'm going to take that negative 2 and I'm going to plug it in for p. So I get 20 is equal to 8 times negative 2 minus 4. So I get 20 is equal to negative 16 minus 4. So 20 is equal to negative 20. Nope. So negative 2 is not a solution. Okay. So solution makes it true. So if you plug in some solution that you've been given and it's not true, it's not a solution. We talked about a linear equation in one variable. You can have linear equation in one variable or linear equation in 2, or you can have a linear equation in 3, 4, etc. But they all have something in common. So in one variable, you have
What's the linear equation?
linear equation. Okay, linear equation is a straight line. So if I were to draw the graph of the equation, I'm going to get a straight line. I'm not going to get a curve or a point or some three-dimensional figure. I'm just going to get a single straight line. And in one variable means that we only have one variable in the equation. Okay. Now to be a straight line, there are certain qualifications. No exponent on the variable. Okay, and then when we get into like linear equations in more than one variable, there's some other qualifications, but for right now, since we're talking about one variable, we have one variable in the equation and it does not have an exponent. And that will give us a straight line if we were to be graphing it. We're not graphing it, but if we were to graph it, it would give us a straight line. So they are written in the form ax plus b equals 0. And that just means we have some number times x plus or minus some other number would equal 0. We could make it look like this. if we wanted to. Basically what I'm saying is you have just an x with no exponent on it, right? And you have some other numbers in there. Another way, another linear equation, that's linear. And the way I know it's linear, no exponent. And it's only got one letter. So that's what we're dealing with right now. As far as how to solve them, we'll get there in just 1 second. Okay? What we have are, you can have equivalent equations, and equivalent equations have the same solution. So equivalent equations have the same solution. So this 3x plus 5 equals 6, I could maneuver that around and make it look different, but it would still have the same solution. We're not going to do that right now, but just to know that if you have the same solution, it doesn't matter what the equation originally started looking like, it's equivalent. So every equation that you get that's a linear equation, that x equals 2, they're all equivalent, even if they look completely different to start with. Sort of like a dollar. If I have a dollar bill, or if I have 4 quarters, or if I have 10 dimes, or if I have 20 nickels, or if I have 100 pennies, it all looks different, but they're all equivalent. Does that make sense? Okay. What's called the addition property of equality. And the addition property of equality basically says if I have 2 things that are equal, I can add the same thing to both of them, still equal, right? So if I have 10 is equal to 10, true? 10 equals 10? Well, 10 plus 2 is also equal to 10 plus 2. I can add the same thing to both sides, and it's still equal. Likewise, the subtraction property of equality tells me I can subtract the same thing from both sides, and it's still equal. So if I subtract 2 from both sides, it's still equal. Does that make sense? As long as I add or subtract the same thing to both sides, it's equal. Now what I can't do is I cannot say 10 equals 10 and then subtract 2 from this side and not from that side. That's not true. It has to be done to both. Whatever you do to an equation, you have to do to both sides to keep it equal. And we use that to solve equations. So if I have x minus 6 equals 18, and I want to know what does x equal. To find out x, I had some x, and I took 6 away from it. So to find out what x was, I would put the 6 back in. Does that make sense? So if I took 6 away, I give it back. So what I'm going to do is I'm going to, if this is minus, I'm going to add. But I can't just add on this side. I have to add on both sides or I'm no longer true. Well, negative 6 plus 6 cancels each other out. And I'm left with x. 18 plus 6 is 24. X minus 7 equals negative 12. Again, I have a minus here. So if I always do the opposite of what's been done. So if they minus, I plus. And if I plus on one side, I have to plus on the other side. Those will cancel each other out because a minus and a plus of the same number cancel each other out. So I'm left with x, and negative 12 plus 7 is negative 5. Y plus 4 equals 5. Here, I have a plus, so I'm going to minus. Those will cancel, and I'm left with y. Y equals 1. Now, which number do you add or subtract? You're trying to get the letter by itself. So you're going to add or subtract whichever number is next to the letter, because you want that letter by itself. It's called isolating the variable. So we want to get that by itself. So if they added, you subtract. If they subtract, you add. You're always going to do the opposite of what was done. Let's do like a couple more. Z plus 11 equals 14. Right, so it's plus 11, so minus 11. So Z is by itself, equals 3. Sometimes they're not in the same order that you're used to seeing it. If this is confusing, you can rewrite this. And I can make this q plus 2 equals negative 8. This is the same as that. If you don't care, you don't have to. This is positive, so I'm going to do minus. And I get negative 10 equals q. Or if, like I said, if you moved it so that it's prettier, that's plus, so I'm going to minus, and I get q equals negative 10. Okay. When you get things that look like this, the first step is always going to be collect like terms on each side of the equal first. Okay, so I'm going to do this side, I'm going to simplify. And then this side, I'm going to simplify. So I want my sides, each side of the equal, to be completely simplified before I start doing anything back and forth. So I have negative 8, 3x, and 2x. Negative 8 doesn't have any like terms, so I'm going to bring that down. 3x minus 2x is 1x, or you can just write x, like that.
Okay, how do you know the difference between it's a negative 2 or a minus 2?
Negative 2 and minus 2 are the same thing. This is more accurate. We don't like to throw the ones in there because, well, that's more to write. But, and then 12 minus 9 is 3. So that's 3. And then I just carry the equal sign down. Right? I didn't do anything with it. It's just still there. Now I've simplified all this side. I can't do anything else to this side by itself. I can't do anything else to this side by itself. Now I can move things over. This is a minus 8. And I want the x by itself, so I want to get rid of this minus 8. So I'm going to plus 8. Which will cancel those two out and leave me with the x. And then the 3 plus 8 is 11. You see parentheses in there? Like this, you always want to distribute first. Then you simplify each side. Then you'll solve. Okay, so first I'm going to take this 2 and I'm going to multiply it by each of those. Negative 5, there's nothing for me to do there, so I just carry it down. 2 times y, and then 2 minus y. Next, I want to combine my like terms on this side. So that negative 5 again, nothing to do with it, so I just carry it down. 2y minus y. So if we want, we can rewrite that next to each other. 2y minus y is 1y, and then that plus 2 comes down.
If it's one line, you can just write y, right?
Mm-hmm. Yeah, you can write a 1y or you can write a y. They're the same. There, do that. Okay, now I've got nothing to do on this side. I can't do anything to just a -5, it's just sitting there. And y plus 2, I can't combine those anymore. So I have a +2. So I want to get rid of that 2. So since it's plus, I'm going to minus, and it'll cancel. And I have y equals, I have -5 and -2. So they're the same sign, so I'm going to add them. Okay.